5 on the nose. Let's do this. Okay. Module number 9, passing the halfway point. 7 chapters left, including this one. And then we have the final at the very end. And like I mentioned last week, if you take and pass the Security Plus exam, then you have no need to finish this class because you achieved the main goal of the class, which is to pass the Security Plus. As always, I got a little picture for the week. All right. I'm going to focus on client security because the user continues to remain our weakest link. We can put the best firewalls everywhere, the best policies everywhere. All it takes is one user to do the one thing they shouldn't and blow everything out. Starting with Secure Boot. Bypassing security on a BIOS chip has been a breeze. With the introduction of UEFI also came Secure Boot that will check the digital signature of the boot software before allowing that medium to run an operating system. If the physical hardware has changed with the hardware root of trust enabled, then it won't boot. This is not like everything else. It is not foolproof because if you enable Secure Boot but you didn't put a password into UEFI, then anybody can go in and disable it. It's a good idea to have it enabled. It's just another layer of security, another check to see that you're running a legitimate OS and not your computer maliciously booting something you shouldn't. But don't forget to put some passwords on the physical box, on the BIOS to prevent this from being changed. If you ever thought electromagnetic spying, like the keystrokes being picked up by an antenna or transmitting data from an air-gapped machine through a power supply, none of this is science fiction. It all falls under Tempest, or the telecommunications electronics material protected from emanating spurious transmission. I have 2 articles in the lecture notes that you can check out, but it is possible to detect what keystrokes are being pushed using a sensitive antenna, or being able to transmit data through a power supply. Of course, these are more extreme scenarios, like at nation state level, attacking embassies, that kind of stuff. But nonetheless, it is possible. And if you are dealing with highly sensitive information, you're gonna want to also have we're gonna have to worry about these things. And I almost forgot to put my chat up. Here we go. A quick refresher of the various types of operating systems. Got your network OS, your server OS, workstation, appliance, kiosk, and mobile. Some general steps that can be applied to most, if not all of them. Disabling unnecessary ports and services. Essentially, if you don't need it, turn it off. Like turning off any background or startup programs, services, and daemons that are not necessary. If a device isn't sharing any folders, but folder sharing is enabled, well, that should be disabled. Disabling default accounts and passwords. Now, everybody knows the default accounts to devices, and everybody knows the default passwords. Those are easily searchable. you should not use those. Employing the least functionality. Systems should be set up to do only what the intended purpose is and nothing more, which is always an annoyance with our users because they always want to do more than what they're supposed to do anyway. And creating application white and black listings. Having applications pre-approved or denied to run on systems. Again, another annoyance to the end user. If we approve to run Chrome and Firefox and they want to run Brave or they want to run Opera or whatever, it'll be a constant struggle with them to find some middle ground. And of course, patch management. Patches don't always work right, which is why you should always test them. Here is a video from from 2010. This is a lesson in why you should test your patches before you roll them out. Let me enable screen or sound sharing. And mind you, for whatever reason, Zoom will raise the volume. So you might want to lower your volume right now.
Welcome back. An antivirus program for PCs goes berserk, you might say, unleashing computer chaos across the country. Security company McAfee says a software update caused its antivirus program to misread a non-threatening file. The mistake caused PCs to reboot over and over again, never fully turning on. The problem even impacted operations at hospital in Rhode Island, police department in Kentucky. And joining me live is Pete Juvenile, systems administrator for the College of Business at Illinois State University. And Pete, I understand you had problems as well.
We did. It was a very busy day yesterday.
So what happened? Tell me how it affected your system.
Oh, sure. We had around about 9 o'clock, we had our first person give us a call that said their computer had just locked up and completely was unusable. And by the time I'd gotten up there, about 3 or 4 other machines had the same problem, and then it just kind of spiraled out of control there.
You're the systems administrator, so I imagine the people are looking at you to solve the problem. Right. and you're as baffled as anyone else on this one.
Well, we originally thought it was a virus up until the point about midway through the morning. We had discovered that McAfee had been causing this problem all along. And what's interesting was it was literally minutes before our 300-seat computer lab was going to check into the McAfee server to download the update.
And McAfee,
and so
they issued a statement saying that we sincerely apologize for the inconvenience this has caused our customers. How many people potentially did you see affected by this yesterday?
Well, it's hard to say because a lot of our people come in at various points throughout the day. Even today, we're seeing individuals come in and report this issue. So we had 3 or 4 classrooms full of students that weren't able to do a class in our college alone. And so we had to address those issues fairly quickly.
Now, McAfee now has a replacement update for people or users to download. Did you do that?
We did. McAfee was really on top of it. It was probably 2 hours before the next app file had come out, and I was just sitting there hitting refresh on the computer screen waiting for it.
Well, they say that they are apologizing again for this, and they've got this, as you pointed out, replacement update for people. So look out for that if you're one of the many thousands affected by this. So thank you very much. We greatly appreciate it, Pete. Thank you.
Thank you.
Absolutely. Well, minutes from now, President.
Yeah. Patches are necessary, but that doesn't mean roll them out as is. Always test before you take them out on your production system. So antivirus was the cause of this infinite reboot. Just because it's an antivirus or anti-malware or some defensive layer update should not mean that it gets a clean pass. Just like operating system updates or program updates, you also want to test these before you send them out into your production, because you might end up having a bad day like this. This is why it's ideal to have a testing environment where you run all these things, you see that it works, and then you roll it out everywhere else. Operating system hardening is definitely an important step in creating baselines for your organization. Implementing things like least privilege, reduce capacity, set file systems to read only, and removing unnecessary features before users even get to interact with the OS. It also works if you do it in tandem with creating a baseline. So not only do you set up the system the way you want, but you also create a baseline for it. Then you'll be able to detect any anomalies once that that image is rolled out to all. Peripherals are an issue. The easiest policy is to just deny all peripheral access to any system organization wide. Obviously, this is not always possible, since many users will have legitimate needs for SD cards, for USB drives, eSATA, NAS, cloud, multifunctional devices like scanners, printers, fax machines, and so on. Don't just apply a blanket approach. Look at your organization or the group that you are securing, see their needs, make it, don't just go blank state, be specific in creating a policy for peripherals. They are a problem because it is totally possible to take a USB device and infect it and then cause a great infection across your organization. But don't just because of that, out of fear, close everything. Be specific to the organization you're helping. Physical security is just as important as digital security. Again, it doesn't matter how well you protect the machines, the OS, you harden the system. It matters nothing if a thief can grab it and run out with it and have no way to prevent that person from leaving the premises. You could use fences with proper signage and lighting. These are passive barriers to restrict unwanted individuals or vehicles from entering a secure area. Could also have cages to be used as waiting stations until a visitor is approved for entry. Could use barricades to block the passage of traffic. Could also use bollards to prevent any vehicle from ramming into a secure area. Adding with these things, you could do things like closed circuit TV to keep surveillance, motion detection sensors, and even security guards who could make split-second decisions and take appropriate action based on the threat that is incoming from the outside. And this is also not covering any of the facilities itself. Internally, and not talking about the routers and switches, you could have screen or privacy filters so that anybody walking down the street isn't able to look at the monitor and see what's being typed. You could have specific door locks. This one is an example of a cipher lock. Now you could have different kinds of locks throughout the building so that one key doesn't open every single door in case it gets stolen, in case it gets copied. Could also have man traps that separate non-secure area from secured areas, creating a physical air gap between the two. Could also use protected distribution systems, or PDS, to protect data that's being transmitted from being listened to outside. And also using things like cable locks to prevent desktops and laptops from being stolen and taken off premises. Another area that you need to watch out for if your organization creates software is application security. Poor coding techniques can create vulnerabilities in applications that attackers can then exploit. Now, though Security Plus is not coding focused, you do need to have an understanding of the concepts, because they will ask you questions about the concepts. For example, the development of an application has a series of steps, and they could be something like development, testing, staging, and production. You should be aware of the development cycles, the waterfall and agile for the 501. You don't have to be fluent in them, but you do need to understand what it is. Waterfall dictates once a stage is complete, the next stage can continue without any means to go back to a prior step should a mistake arise. Agile does not work incrementally like waterfall and instead follows an incremental approach. DevOps and secure DevOps fall into this criteria with topics like security automation, continuous integration, immutable systems, infrastructure as code, baselining, change management, provision, and deprovisioning. But more often than not, you're going to find DevOps teams who don't employ secure coding measures, which is why there are so many vulnerable applications out there. So here's just one example of a waterfall. Here's an example of agile. Again, you don't need to be fluent in agile and waterfall, but you need to understand what they are, because there are questions on the test that will ask which of these is agile, which of these is waterfall, and basic questions on the two. You don't need to know every step. You do need to understand how they work. So I've given you links in the lecture notes for you to dig further, and I've put a bunch of terminology in the lecture notes for you. That's about as deep as they're going to get. Some secure coding techniques that you will be asked about. These are some best practices to create secure applications and limit data exposure when in production. Do things like proper error handling, taking the correct steps when an error occurs so that the application doesn't abort unexpectedly. Proper input validation, as you saw with a web application. Account for errors from user input. Normalization, something that, again, you saw from web app. Organize data within database to minimize redundancy. Store procedure, having a subroutine available to all apps that access relational databases. Having code signing, digitally signing the apps cryptographically. Obfuscation or camouflage code, writing an application in a way that its inner functionality is difficult for an outsider to understand. Dead code should be gone, sections of applications that executes but has no meaningful function. Server or client-side execution and validation, input validation by either server or the client side, and code reuse of third-party libraries and SDKs. use existing software in new application. SDKs are a set of tools to help you write apps. In order to test code, there are some methods outlined that show up in the test. Model verification. Test to ensure the projected application meets all specifications at that point. Compiled code testing. Search for errors that could prevent the application from properly compiling from source. Runtime code testing. Test the code live in a sandbox. Static program analyzers. Examine the software without actually running it. Fuzzing. Deliberately provide invalid, unexpected, or random data as inputs to see what errors are trapped. Stress test. Put an application under a heavy load to determine if the program is robust and can perform all error handling correctly. And integrity measurements. The application is running a set known and approved executables. Again, it's not, you don't have to know all these things in depth, but you do need to understand these because you will see these on the test.
The recording has stopped.
Move this over.
This meeting is being recorded.
And switch what I'm sharing. Like prior weeks, you will be working in TryHackMe. And just as before, if for whatever reason the rooms are not available, just find new rooms that still meet the conversation that is going through this chapter. I also have linked to you StigHub, where you can search Windows and Linux guidance steps. Find at least 5 for each OS and implement them on a cloud system. So take a step back. Here's StigHub. Let's say Windows Server 2019. See what we get. You'll find a list of things that you can apply to this OS. Find at least 5. Enable them. And see the result. Does it change the functionality of the system? Does it make it more secure? How does it improve the system? My suggestion is run this in your cloud VM because it's the easiest to run from there. And if you make a mistake, it doesn't matter. You just delete that VM and start anew. So find at least 5. And there's quite a list here for you to search through. So don't feel at all that the first 5 will appear. There's plenty to search through. Apply them, see how it improves the system, and just write a short thing about it. It's not, you know me, I don't expect long essays on this stuff, but I do want to see that by doing things like this, you're understanding what you're doing and you see the benefit of it. Are there any questions? Cool. Then you know, as always, if you're stuck, ask away in Discord. Never feel that you have to do it all on your own. Feel free to work with others. But yeah, knock yourself out.